Hey everyone, welcome back to my YouTube channel. If you are new here, do not forget to hit that subscribe button and like the video so that you don't miss any videos from our channel. Today we are going to solve a lead code problem called count good nodes in a binary tree. And the definition is simple. A node x is called good if there are no nodes with a value greater than x on the path from root to that node. And the root node is always considered to be good because there are no nodes above that. So let's check a few examples. In this tree, you can see that our root is defined as 3, 1, 4, 3 and then null 1, 5 and output is supposed to be 4. Here the good nodes are 3, 4, 5 and 3 and that is total of 4. So output is 4. And in example 2, we can see that our root is defined or our tree is defined as 3, 3, null, 4, 2 and good nodes are only 3, 3 and 4. So that means answer is 3. And in the example number 3, our root is defined as only 1. So the output is also 1 because root is considered as good always. The rule number here 2. So the approach, how do we solve this? We perform a DFS, depth first search traversal of the tree, and while traversing we keep track of the maximum value seen so far on the path, and if the current node's value is greater than or equal to this maximum, it's a good node, and we update the maximum and continue the traversal, and in the end finally we will return the count of good nodes. So let's look at the Python solution for this problem. We will define def dfs of node comma max well if not node return 0, and we will consider good equal to 1 if node dot val greater than or equal to max underscore val else 0. Here we are defining good is equal to 1 if node dot value, if that node value is greater than the max value seen so far, otherwise it will be 0. And then max underscore value will be defined as max of max underscore val comma node dot val, and good plus equal to dfs. We will be adding up all the good values that have been seen so far. So dfs node dot left, we will perform dfs search on the left node, and we will pass max underscore value, and then again we will update good plus equal to dfs of node dot right comma max underscore val, and at the end we will return good, and out of this function we will return dfs of root comma root dot value. So let's understand what is happening here. We defined a recursive dfs function, and if a node's value is greater than or equal to the maximum so far, we will count it as good, and we then recursively check its left and right children here, and finally we return the total good nodes in the tree. And this solution runs in big O of n times since we are visiting every node exactly once. So now let me try to run it and check if it passes all these three test cases or not. As we can see here that our code passes all these three test cases. Now I will try to submit it and check if it works from all the test cases available in this problem. How does it perform compared to other users in terms of time complexity and runtime complexity? So let's see. As we can see here that our code surpasses 85.72% of users in terms of runtime and 64.37% of users in terms of space complexity. So that's it for today's video, and if you found this video helpful, Do not forget to hit that like button and share and subscribe to Geeky Code for more coding interview problem. And thanks for watching and see you in next video.